Yo, 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 it's your boy Van. We're out here. It's probably about 9 o'clock at night. Just went in and got a bite to eat, but just wanted to kind of show a little picture. That's through the windshield, and this is through the side window. It's pitch dark outside, and we've got a lot to go over. This is going to conclude our third and final electrical video. I still have quite a bit to do, guys, but just wanted to show you guys. I've got this can light temporaried in, and as you can see, excuse the mess, guys, it's been a rough day. I started early this morning, and it's, like I say, 9 o'clock at night. So we have went round and round today with lots of work. Get this door closed. Woo! Kind of chilly out there. Oh, it's got to be probably freezing already, I would imagine. Before we get into that, I just wanted to share with you guys some charts. Actually, we will roll into this one next. This here is for, you guys want to take a screenshot of that, I'll back up. Hopefully you can get it all, or we'll just kind of do a scroll down. Also, I don't know if you got a screenshot of that, or I tried to get it all in one picture for you guys, but this is for the Chinese diesel heaters. So maybe you guys forget where I picked this up. I'm not sure that it came from a per se manufacturer. It's been quite some time, but this allows you to set your minimum speed for the fan and the pump and everything. And this is for the altitude where you are sitting. So I'm around 4,000 feet here. So, those would be my numbers. And that's probably pretty much going to be the, main area right there. Not too many of us are going to go up above 10,000 feet. So you can probably get a shot of that. So figured that would come in very handy. I looked, high and low for that. And that's about the only thing I could come up with as far as specs on how to program that thing. So I'll zoom out on this one too. This actually came from Renogy as far as their batteries go. And I just have a black and white cartridge printer. I think that's what they're called. Yeah. Did away with the ink cartridge. We just don't print too often. So what ends up happening is the ink dries out. Every time I want to use it, I need more ink. So my nephew, being a little smarter on the computers and stuff than I am, he said, just get the cartridge type printer, and you won't have to go through that mess with stuff drying out. And I said, well, I really don't even need the printer to be in color. Just black and white would be sweet. So I kind of penciled in a lot of this stuff, as you guys can see here. I'll zoom in here a little bit. This is for Renogy batteries, and I would say it's probably pretty close to different brands. It'd be nice to get your own specs for your particular brand, but I just came up with this information. I had to kind of dig pretty deep to find this too. So 13 volts, which is what I'm at. I have AGM batteries. If you're going to opt for the lithium, here's the lithium information over here. So as you can see, lithium stays pretty strong all the way down, and then it just nosedives at the end. It's going to fall out pretty quick towards the end. So most of your power is going to be up here. That's why you got 100%, 100% all the way through that. And as you can see, as it gets lower and lower, then, 13.2, 13.1, 13 volts, you can see a significant drop in the percentage of the battery life. Because, people ask, well, what is 50%? Well, on my particular batteries, I have the AGMs, and they're also sealed lead acid AGMs. An AGM, if you've ever been curious about that, that stands for absorbed glass mat. So it's just different technology within the batteries. They design them to do different things, like starting your motor. You want more cranking amps. If it's for solar applications and things like that, they just have more cycles. So it's just different technology on how they build the batteries. But that just kind of clues you in there. Just a normal flooded lead acid battery. There's your specs there as well. So I can take this down to 12.5, guys. And I wrote this out here. The depth of discharge, that's your DOD, at 50% without harming the battery. So every once in a while, if you go in this area here where the 11.95 and the 11.9 on the regular flooded lead acid, those are kind of cautionary areas. If you allowed that to happen every once in a while, just try not to go below that 12.5 for me example, 12.05. Every once in a while, accidents happen. If we went down to the 11.81, we'd still save it without doing any permanent damage. So once you get into these areas and you let it drop down in there, you actually have kind of taken some of the life off your battery. So I just wanted to go over that real quick. As I said, I got this guy here just temporaried in. Finished up a little bit more of the ceiling today. We got a few more boards over in front of that cabinet. So we're going to make that curve down, but I still got to wire this stuff up. So, you can see nice little can light. And when I left, I haven't looked yet. We're going to check this out. I got another extension cord plugged in here so we can get some good light in here. Why didn't I turn that on for you guys to begin with? Show you guys what we've done over here. This is our temp wire that I've got running up to that light, so just ignore that. This is going to be 120 volts is what we're going to get to next when I get that panel put into this little miniature pony wall here in front of the water heater. And then we'll have a countertop to cover all this stuff up. So it's just been my little trash box today. All my strippings and stuff. And that's what I was wondering. I wired up this monitor here that was set at 13.2 when I went into the house. Oh, I'd say a good over an hour. Probably around an hour and a half, especially with me filming now. So that light's been burning for about an hour and a half, so we lost 0.2 voltage on that battery bank I got down there. So we got our fuse panel all tied in. Everything's tied in. This actually has a cover that'll go over top of everything to protect the lugs and such. So we burned up every circuit in that whole entire fuse panel. And I could have probably ran a couple more, but, not that big of a deal. We'll make do. So if you go back, a while back, I went over the Uglies book, which is an electrician's reference book that we carry around religiously in the trades, because we just don't have all these charts and things that, amperages and, the insulation of what the type of insulation, all that stuff matters when you're trying to figure out what amperage you want to hook up to a wire. Like I said in the past video, With DC voltage, we want to go a little big. Don't be shy. Because you're going to run into voltage drop and things like that with DC voltage. AC, we don't have to be too concerned. Once it goes through the inverter and we're putting out 120 volts alternating current AC, you can run the rated amperage to the wire. So depending on the insulation, of course, that's why you need the chart. But I did a video in the back and kind of laid you guys out on the Uglies book and actually showed the actual chart of different types of insulation and what it's actually rated for and things like that. So that would be a good reference to check as well if you're in the middle of doing something like this, to make sure you're getting your amperages correctly with the wire size and the type of wire that you're running. Now, DC is a little bit different. I forgot that website. I'll do that in a future video. Maybe I'll do a short on it or something. But there's a killer website that just, you can type in the information, the length of wire, and everything. It'll figure out exactly what size wire you need on the DC side. But for the most part, with little stuff like this, branch circuits and stuff, I usually just kind of shoot from the hip, guys. I know a lot of these little wire sizes just by heart from running them for so many years. So like this here's a number 6 THHN. That's rated for 50 amps. So I'm probably going to be putting out a maximum of probably 30, maybe 40 amps or something out of here at one point in time. It's like, in your house you have a 200 amp service, but you don't have all the lights on and, a welder shut on in the garage and all the lights in the house and the fart fans and the stove and water heater and the jacuzzi tub and then the hot tub out back or whatever. That's rated for the entire house. So basically, this is the entire house, and how many things am I going to be using at once? So that's what I mean. I'm probably going to be using, half the amperage of the 60, but I am fused at the 60. I had the 60 laying around, so it worked out perfect. If there's a dead short, it's going to trip that breaker, and that's a breaker too, I might add, which works great too because it also works as a disconnect, so you can turn it off. So if we work our way back down from 6 THHN, I say it's rated at 50 amps, but I'm actually wrong on that if you check the charts. But this is just like a US standard. Once again, just kind of a little leeway. I think it's rated at something like 70 amps, but then there's derating if you're going to be running things across the top of a roof and temperature changes, in hotter environments, you want to run a bigger wire size anyway. So our standard here in the US, we run number 6 to 50 amps. Number 8 is the next size down from that. I actually have a number 4 coming in from the batteries. So this is even one size bigger than the number 6. So the 60 amp, I'm definitely protected with the number 6 here because, like I say, it's rated for, I want to say about 75 amps or something technically. So and then, the power actually coming through it, like I say, probably around 40 amps at the most on a heavy load day. So we're dialed in as far as amperages and wire sizes. And I'll work my way back down on that just to help you guys out if you don't want to flip back to that Uglies book episode I did in the past. So 8 is 40 amps. Number 10 gauge is 30 amps. Number 12 gauge is for 20 amps. And so on. So a lot of this stuff here, I don't even think I ran any 14 gauge. 14 gauge would be for 15 amps. So all this stuff in here, I'm sure is number 12, if I recall. There might be a piece or two of something smaller, but it would be controls to feed this. I think I have a little tiny guy here in particular, that different color fuse there. It's a little small baby wire. So I just put a 5 amp fuse in there to feed the controls for this thing. This thing is dynamite, guys. Should have left the covers off, but they're just lug bolts in there where you land your wires. This side here would be the, let me think here, without having the cover off. See how good the old memory is. The top right is for all of your negatives from the alternator, from your battery bank, from your solar panels. All of the negative stuff lands on that one lug there. So I did, bugged everything together back behind this board. I think we showed that in the last video. All this stuff still needs to be tied up. There's a bunch of control wire right there that's looping through. So that's in a little tie wrap. So, but we've got that all bugged together, all three. And then I bring it out in one and land that negative side there. This top right, once again, going off of memory, I believe that's the solar hot. So that's coming from the solar panels. And it says on here, guys, if you buy the unit. I want to say that one comes from, yeah, that one's from the alternator. So you could take that to the positive side on your battery as well, up front in the motor compartment under the hood. And that guy there goes back down to the battery bank. So very simple setup. This just means pretty much everything's at idle right now. There's another light here that comes on once the sun comes up in the morning, and then that'll bring the charge in, so that identifies that. And this here's a picture of an alternator. So if we start the vehicle, it also sends a charge back to the battery bank from the motor. Once the battery bank is totally full, this will actually flash periodically, which means it's sending a trickle charge back up to the motor. So that's another reason this thing is really cool. I love this thing here they come up with from Renogy. I want to say it's rated for 40 amps, if I recall. That might be just the solar incoming. Maybe that's maxed out at 40 amps, but I want to say it's probably 40, 50 amps or something charge coming back into the batteries. This here, another control wire. This is our thermostat for the furnace. I still need to get that programmed, so that's when we turned the power on. So everything was just set there. That's our breaker that comes down to our fuse panel. All the branch circuits going out to everything. This is a little gizmo I hooked up, which is really nice. Let's open from this side. We got USB ports, 2 of them here, along with a couple more I did on this side. This way, in case I want to lay something this direction over towards the washing machine or set it on top of the refrigerator, I can route wires that way. And if we want to, this is going to be countertop over top the water heater. So if we just want to plug something here, or we could come up in this cabinet as well. So this is the old cigarette lighter, 12 volt, just to plug in things that are cigarette lighter operated. So we're still sitting at 13 volts, guys, with that light still going. I mean, we're working on 2 hours here. So I'm really happy about that. If we zoom around here to the rear of the van, I cut a couple holes. That's where the can lights will be going there. One to the right will be over top of the shower pan. We flip that hatch and our shower pan's down below. And the left one will be nice as well because this door opens first. So just a quick entrance or something. I'd like to have a light for that anyway. This one's, it's a little more complicated. Just in and out stuff, you're going to be over on the right side. So, but the one on the, or left side rather, the one on the right side we need for the shower. So that worked out really well too. And I'm kind of debating on the layout on these other cans. That's why I wanted to get this guy up tonight and temporaried in to see how much light it actually put out. So we're going to be in this row here because I don't want the cabinet doors to shadow over top of the lights. So it'll be in the same row. We've got them there in the back. So I'm thinking 2 more on the other side of the fan here, and probably 2 more up here. But I was thinking maybe 6. But, you know, kind of up in the air. Undecided, really, just how I'm going to lay that out. So we're definitely going to have 4 more cans, 2 more in front of the fan there, and then 2 more before we get to the AC up here. And those will probably be switched all the same. These 4 here, the ones in the back I'll switch probably separately. If you're in the shower, you can just have that one on. If you come in the back door or something, you can just turn that one on if you need some light back there. This will be switched separately. Put this pretty close to the slider door. And the reason for that is if, you know, we're hanging out outside and we just want some light in the van or something and leave that slider door open, I don't think it'll create too many bugs. So they won't really see the light itself. It'll be kind of hidden behind this wall here before the door is, you know, open there looking straight in. You won't even see the light, but you'll see that the van is lit up pretty well. Plus it illuminates the front entry pretty well. Of course, we got this other big LED on right now, but and the other reason I kind of tucked it back is because we're beyond this cabinet here as well. So if you're in the back facing the front of the van and we're trying to get, you know, watch some TV or something up this way, then, you know, this light, I should have spun the other way. So I got stuff in the floor and, oh, it's a mess in here, boys. But, you know, I didn't want that to kind of glare the television. So that's why I kind of tucked it back behind the cabinets on that as well. So I think that kind of sums up everything. Trying to think of any other questions that I can maybe answer. Oh, tool-wise, all those crimps and stuff, you're going to need, you know, like a pair of these. These are a little bit more industrial type. You can use a cheaper set. Where's that other little guy? I've been using that on and off today with certain things. I just used it earlier, and of course I'm not seeing it now. But you know, any auto parts store. I'm going to show you. Oh, here they are, sitting over here on the washing machine. So this type here, get a similar type to this here, and these strip the wires, and then you can do the crimps on, so you guys know what I'm talking about, the crimps there that we landed. So, you know, all kinds of different companies that make these. Here's a Panduit, another one's called Stake On. You can get forks, you can get circles, you can get little couplings if you need to add a piece of wire to it. These things are called Wagos, and they work really good for stranded wire. A lot better than just a wire nut or something like that. And I really didn't want to get out soldering iron and do it old school style. So these Wagos work really well if you can get the wire up in there. They don't pull out. So they work really great for little splices like that if you need to make a splice. Or you can just use what they call a barrel crimp. So it's just, you know, no fork, like these are forks, what they call. So there just wouldn't be a fork. The barrel itself would just be longer. So you can crimp them together doing that as well. Always handy to have some kind of little, you know, meter so you can check voltage and stuff, of course. I think that about sums it up. It's just been a long day for me, so I'm going to get some rest. We're still sitting at 13 volts, guys. I got to be a couple hours in now with that light burning. And that's the other reason I'm going to switch that one separate, because I think it'll make a good night light. These are AGM batteries, and I probably would say definitely in the summertime. We're on short days right now, but definitely in the summertime when the days are longer, I would say that light could probably be left on all night long with just ease without getting down to our what? Our 12.05. So that's the, I think you guys are getting a glare there in front of that light. The 12.05, that's the number that I particularly don't want to go under. If we do, every once in a while, like I say, as long as we stay above that 11.81, we won't do major damage to the battery and take away its life cycles. These are rated for about 600 cycles, and I'm going on about pretty close to 2 years with these batteries. And they've been cycled every day. Some, once again, they're Renogy batteries. So I can't really say anything bad about Renogy. I've had some good experience with them, guys. Like I say, I love this box here. Lose my voice, but 300 and 300 days in each year easily, and it's cycled up and down every day and every night, because I've had the refrigerator going on and some other things that draw some higher amperages. So I'm definitely getting down close to that 12.05 for the last 2 years with the refrigerator running. I don't have that hooked up right now, so that's why we're not dropping below that 13. I got the fuse pulled on it, but just wanted to see what kind of draw that thing was going to drop my battery. So it'll be a nice little night light. Can sit there in the back and watch some TV and have this on. A nice little night light that can be kept on. It just draws barely anything. It won't put a glare on the television because it's behind the cabinet. So that was all pre-planned, like I said. And I just got a bunch of wires to run here and there. A couple more USBs. I want to put probably something up here in the side cabinet here, maybe a USB plug-in, so something can drop down here to the kitchen sink countertop. And get these lights dialed in. I might do something up underneath the cabinets for lighting. Haven't decided on that yet. We got the hood range to still put on over top of the stove. So that'll be dealt with next, because we got to get our other wall put in, so it'll be white and pretty just like that one. And, throw some insulation in there before we cover it up, of course. And there's our freezer. We've got that wired up. I got the fuse pulled on it right now. So there's a chest freezer underneath the bed. Just in case this is your first time watching the show, I've got a dryer here. Here's a wash machine. And here's our refrigerator that stands probably a solid 4 foot tall, I'd say. It's a pretty good sized fridge behind the driver's seat. And that's made by Unique also. Wonderful product. I got it from HomeDepot.com. Just a little input there if you're interested in that. So, till next time, like, subscribe. I sure appreciate you guys watching. I hope you learned something from these 3 episodes and builds a little confidence in doing some 12 volt electrical wiring. Like I say, our next get into is going to be the 120 volts. So I've got some things kind of tied into that temporary power, and we're going to get that built into a wall right there beside the water heater, as I said, and get that all tied in permanently like this is all looking here. Looks a whole lot better than it did. A lot more organized. Also, I don't know if I mentioned, this is 120 volts here, and that's going to go right in between here. We're going to put us a plug here, probably a quad. So 2 receptacles, and that way we'll have power above this countertop here once this goes in. So we'll have 120 volts, all the 12 volt you can ask for. Got 4 USBs, and you know, a cigarette lighter plug in there. And I've got another one of these. So I can split these up and take them out of this frame, which I just may do, or I may just install it up here on the side of this cabinet. Like I said, I wanted to put something up there. So cross that bridge when we get to it, guys. So I appreciate you guys watching. As usual, any questions whatsoever, drop them down in the comments. I'm always eager to try to get back in touch with you guys and get you the right answer. You know, if you're having troubles, I hope I built some confidence, told you, you know, what you need to know to do it right, to keep you guys from starting a fire after doing all this work. And then, you know, God forbid you had a spark in here and, you know, catch your whole build on fire, and even worse if you were asleep in the bed. So you really want to do this stuff right, guys. Every wire in here should be fused. I've got still a few more, like this feeder from the battery. I think I mentioned on the last video. I've got another monitor that I need to hook up to the batteries also, that's going to come up here. That one's actually made by Renogy, so that one's going to go up here too. It's a little more technical than just a voltmeter. It shows you percentages and stuff on the battery and stuff. So I need to get down in there and get to the battery, so that's when I'll fuse that wire. But, you know, it's technically fused from here to there at this point, so it's better than it was, because this is where our load is. So if we got any issues, it's going to be on this side most likely anyway. And it's just me working on the van, so I've done this all 100% myself, so it's been slow, ongoing process, but we're just about there. So till next time, like, share, subscribe, leave some comments in the bottom section, and we'll see you on the next one. I think that about sums it up. I sure appreciate you guys staying with me through this long series. Peace out. Peace.